Hello and welcome to session 247 in the AISafety.com reading group. Tonight we'll be discussing the article Eliciting Latent Knowledge, How to Tell If Your Eyes Deceive You by Paul Cristiano, Aya Kotra and Mark Su. This is the first work that's been done publicly by the Alignment Research Center, a new AI alignment organization set up by Paul Cristiano, as well as Aya Kotra, who is technically working for OpenFlow, and Mark Su and several others. This is a post that is recently new from the December last year, and it's 56 pages, which means that we probably will not be able to go through everything in one part. We've taken the first 20, we're going to cover the first 20 pages now, and I'm thinking of splitting it into 4 parts so we also can get some comments from Les Wrong added to this. Also, the subtitle, How to Tell If Your Eyes Deceive You, doesn't seem like it's really relevant. Okay, so eliciting latent knowledge sets out a toy scenario called the SMARTVAULT, where a diamond in here needs to be protected by a security system which is extremely complex, and in fact so complex that it can only be operated by an AI. The AI controls the camera, observes via the camera, and controls actuators and opens doors and things like that. And the humans can as well look through the camera, but can't really operate the SMARTVAULT. It's too complex for that. So that's why the AI is trained to operate it. So if we try to unpack the analogy in this case, the diamond that is supposed to be protected, it's sometimes, I would guess, maybe human values that are kind of like the diamond that we want to protect. But I think it makes sense to think about it in a bit more concrete way, or slightly more concrete, to call this like human power or credibility, that humans are in control to some extent. That's what we are trying to protect. And the thief could be a malicious superintelligence trying to take the power away from us, and the defending AI is a superintelligence that is unaligned, so it's not truly on our side, and that's the key problem. This metaphor, the way I explain the metaphor, is not written in the article itself, and it seems to me that it might in fact not be the intended interpretation. It is quite possible that the defending AI and the thief is in fact the same agent, and I think that could give some different intuitions. It is perhaps in fact this AI that is controlling the SMARTVAULT that we are afraid of. Okay, how does this AI work? It's using model-based reinforcement learning, where it searches over the space of all the actions it can do, and then take the action that seems to have the best consequences. And the key part of the AI that does this is the predictor that, given some input from the camera and a set of actions that it chooses, then it predicts what the output of its action will be. So here is a simple example. We see that the door is open in this picture, and then we change some actuator, and then the output here is that the door is closed. Someone is coming in here in the next example, and then we manipulate this widget, and the person fell in down here and don't get the diamond. And these are 2 simple examples. In a more complex example, we might see a thief entering and a set of actions being taken that are too complex for us to really understand it. The only thing we can really see is the prediction afterwards, which is that the diamond is in place, the door is locked, and everything is just fine. So if we want to figure out, like, that was the prediction, and we want to figure out what should it do, well, then we train it on human evaluations. In this case, it's performing this action, and the output is like this, and the human judgment is that this is fine. If it does something else, manipulate some other widgets, the results also are fine. And in the final case where we do this, it ends up with the diamond not being placed here and the door is open, and that's something that the humans then evaluate as something bad. Okay, simple enough. What is the problem with this scheme? Well, the key problem is that we're training for the input of the camera, which is just not truly what we care about, but a proxy in the sense that it's just a picture of the camera, and it could be replaced by a fake diamond or a picture of a diamond or something other than just the safe diamond. So that's the key thing we want to avoid. Perhaps the most trivial way is to add a second camera, but this gives us very little, in the sense that if the system is sufficiently sophisticated, then they'll be able to defeat all the sensors. And in practice, making sensors independent is really hard. Like, it's very often that an attack that defeats one sensor defeats more sensors, but at the same time, we obviously want to have as many sensors as possible with like a layered model of security. That's obviously what you want. But the real problem is that it's a situation that is both dangerous and probably very unstable. The idea that the AI is looking for plans that will deceive us and that it holds back critical information seems like something that will very soon, as AI capability scales, end up with a stolen diamond. Another way we could go around this is to say we'll only have the AI do plans that humans can understand. The authors argue that in that case, someone will probably deploy an AI that executes plans that we don't understand, because there's probably a huge incentive to do so. I think they go over the existing literature a bit fast here. Like, to what extent human oversight can be scaled is an open question, and there's a lot of research being done, also by the authors, by the way. So it's certainly possible that we can get by with an AI that is competitive and only making comprehensible plans. But that's outside of the focus of this paper. What we should do instead is ask questions to the AI, because the model will know something about its own sensors, in particular whether they are reliable. Because if we imagine that there is the diamond is replaced with a fake diamond, and the sensors will show this, and the AI knows that the sensor will show that, then it seems that this knowledge that the diamond has in fact been taken and our sensors are not showing us the true picture is in the model somewhere. This seems to be an easier problem than many of the other issues we look at in alignment, because we don't really care about whether the AI is lying to us or deceiving, or what its intention are. These kind of tricky philosophical questions. We're simply asking, is the real diamond at this place? And that's like an objective question, and possibly a lot easier to get a handle on. Depending on what the diamond is a metaphor for, of course, it is still substantially challenging. Like, if it means like human values, if the diamond is human values, then that's obviously philosophically challenging. Also, if it means corrigibility or power or things like that, that's also highly non-trivial to specify. But the authors say that if we can get an answer, then we don't need to understand how we got the answer or why we got the answer. I think that's pushing it a bit too far, actually. In particular, if we ask the AI to evaluate some kind of suggested course of action, and the AI evaluates that this will cause everybody to die, then I think we would really like to know why this course of action would cause us all to die. So I think the goals of interoperability with this are a bit wider than just a yes or no. So let's try the first baseline, the first easiest way to deal with this problem, and to see how this fails, and then iterate on it and see if we can end up with something that really works. So this is the symbol for the AI, and it starts with the first part of the video where we see perhaps an intruder entering and an action sequence, and then there's some work being done to figure out what's going on inside the AI. And then the AI makes a prediction, and then it outputs a predicted second part of the video. And what we want to do is to tap into this the part of the AI that is figuring out what's going on, and use that to make a new reporting module. Given this reporting model, we can ask questions like, is the diamond still in its place, and get an answer. So we want to reuse this part. So that's the strategy for the first try. The strategy for how we'll train the AI in this case is to generalize from easy questions to hard questions. So we imagine this is the gray area here is the space of all actions that the SMARTVAULT could take. And in some easy cases, we can tell that if we're in this part of the action space, then we can tell that the diamond is safe, and in this part we can say that it's been stolen, and mostly we can't really say anything. And so the hope is that that we can train on something in this that generalizes to the gray area. We would prefer to train on what's going on, what is really happening. Is the diamond really safe, instead of training on this video? But if we can't reliably tell in these situations, then we can't train on. So the idea in this training strategy is to look for questions and ways that we can tell, are we being misled in some way? And this, the advantage of this is a question about how does the world look like, and is the world in this particular state? And the hope is that we can generalize from this to the big gray area, because the generalization goes through English, through some of the concepts that we use, like what is a diamond and what does it mean that it's safe. So it will generalize also to cases where we can't really test and check the AI's answers. My intuition about this is that this is probably something that's going to fail. Obviously, this is a really hard intuitive thing to get your head around. What is the true concept space that a really powerful AI might find, and how distant is that concept space from the concept space that is represented by the English language? And my intuition is that these two are very different, and a lot of people have different intuitions, and something that I can't go into many details about here. I just want to flag that my intuition is that this gray area here is very, very big and very different from our thoughts. And so the overall strategy of eliciting latent knowledge is to we have a training strategy. We just saw a training strategy, and we want to find counterexamples to that, and then we want to improve the training strategy, hopefully ending up with something where we can't find any counterexamples. That's Paul Cristiano's overall strategy. I think in security, this is in computer security in general, this strategy is often frowned upon somewhat. Everybody can roll their own crypto to the extent that they can't see any errors with it, and that doesn't mean that it's safe. We would much prefer to have some kind of theoretical understanding of why something is safe. But that seems hard, and what Paul Cristiano is doing is certainly better than nothing. So let's figure out what is the problem with this training strategy. In order to dig into this, there are two subtopics that we need to investigate in details. The first subtopic is the original prediction model. How does that work from an internal point of view? Because we want to reuse that in the reporting module, so we need to have some kind of understanding of what's going on inside. And the second part is the human that constructs the training data set. How does the human answer these questions? Because obviously the humans are not outputting videos directly. Humans can do it videos input, but they can't output videos. So humans must be answering some kind of questions about these videos instead. And how do we do that? To talk about how the AI could work, or we assume the AI works inside, I'll introduce the concept of a Bayesian network. Here is a simple example of a Bayesian network. There are this node here corresponds to rain. It can either rain or not. In this case, it's given by truth table here, 20% probability of rain and 80% of no rain. There is a sprinkler that can be turned on and off, and that depends on whether it's raining. If there's no rain, it's on 40% of the days, and if there is rain, then perhaps very few times it's still turned on, maybe by error, maybe because it's only raining very little, whatever. Then this influences the proposition that the grass is wet, and you can have this beautiful, this more complex truth table to represent whether the grass will indeed be wet. And it's possible to calculate down this really simply easily from whether it's raining down to whether the grass is wet. And you can also do inference backwards. If the grass, you observe that the grass is wet, will it rain? For this purpose, it's easier, I think, if you consider this a causal network. Bayesian networks in general are not causal networks, but if you think of all of this as causing each other, like happening at distant points in time, then that won't matter for this sake, and it's somewhat easier, in my opinion, to look at causal networks. We have more information about this. It has to be directed acyclic graphs, and they're generally sparse, so they're not like arrows from everything to everything. And working with this is in theory, you could, like, if you had a good model, it could be something really powerful, could be AGI or something like that. Making optimal inference is that in a Bayesian network is hard. Constructing a good Bayesian network is very hard. Getting guarantees are very hard. Doing Monte Carlo inference on a Bayesian network is often something that works. Like I'm summarizing a research topic into 3 letters, okay, question mark. Like, this is something that could, in theory, be what an AGI is built from, in theory. Okay, let's have a look at the first question. How does the prediction model work internally? So in this case, we have the AI in this corner, and this is like its thoughts. So it has the action here that it's taking. It has a the first video and the second video, which is the prediction, and then it has a number of underlying, I guess P is perhaps for predicates. Could be like how many thieves exist in the world, and is the person walking by the vault going to try to get into the vault, and like what's the status of the door, and what will happen if this actuator, if I turn it right, then the door will close, and somewhere in here is like the status of the diamond, and this kind of thing, and all of this is used to generate this prediction. In the case that we're really interested in is the case where the thief enters, and then the thief puts up a kind of a screen here in front of the camera that shows that everything is okay, and then he steals the diamond, and then the predicted video after that will be a video that shows that everything is perfect. So this is the thing where we're worried about, and in this case there is in some sense we're predicting that we will see this, which is actually this screen in here that has been set up, and if the model expects this, that means that somewhere in this network, somewhere in the inferred joint distributions here, there is in fact the knowledge that our senses are being tampered with, that the camera is being tampered with. The network knows this. This is what is called latent knowledge in the paper. Like, I am not an English speaker, but I'm not entirely certain that latent is a good word for this knowledge that's kept inside these P's, because latent to me means something that is not used in some extent, and this is indeed some knowledge that the information in P4 here is in fact used in the prediction. So maybe you could call it something like underlying or something, eliciting underlying knowledge instead of latent. I don't know, I don't have a good synonym. So that was the first thing, how the model works. The second part is, how does the human work? And here we're making the assumption that humans basically work in the same way. Humans also have a Bayesian network inside our minds, and it works in roughly the same way, just of course worse in this assumption, with this worse than a super intelligence. Like we have fewer nodes here, and when we see this kind of thing, we also try to update backwards. If we're seeing this, that probably means that there is a rubber going into the smart vault, and we see this, then that probably means that the question about whether the diamond is safe is contained perhaps in H3 or H4 or something like that. And in particular here, in this case, one of the things, like the paper is not really clear about this, but if you notice here, we are seeing the symbol that was used for the complex action. So in this example that is being given, the inference that the humans are making is probably poor, because the humans don't understand what the complex action do. But it's a bit unclear precisely what scenario we're talking about here. We could just be talking about any scenario, and in general, how do humans answer questions. And so let's go for the actual question answering, because again, humans don't output video. Humans output questions and answers based on our internal model, and the question, does the rubber take the diamond, is something that can be answered by the joint probability distribution of H3 and H4, and the answer in this case is no, the diamond is safe. So that's the answer from the humans. And in particular, I think that we might in fact be in this case, where what is going on is that we are the humans are not staring at reality, but staring at this picture here. So when the humans see this picture here, they think the diamond has not been taken by the robber, but in fact this is just a picture. And in this case, this complex action is one that has caused the robber to be able to take the diamond. So in this case, the human is actually answering the question wrong. This was not obvious to me the first time that I read the paper at all. So it's also possible that I still misunderstood, of course. So a short digression, using Bayesian networks as both for something that the human is using and what the AI is using. Is that too oversimplified and unrealistic? Well, the authors mentioned 5 ways that you could do better, 5 concrete ways that would be helpful if you're building an AGI. Then you could do better than just naive Bayesian networks. And I think, like, in principle, it's bad to speculate about this kind of thing. I would have preferred that Paul Christian just said, obviously there are many ways to do that better, instead of explaining what he thinks are the best way to improve this towards AGI. But his main point is that even if this is an oversimplified, then we want our training strategies to work for simple AIs. And if we in practice end up with a more messy solution, probably that's going to make the task a lot harder and to make an honest reporter when everything is based on heuristics and things like that. So we want to look at the simple cases, and in the simple cases see if our training strategies work, and that seems like a useful first step. It's a useful first step if you can in fact find something that always works. Like if you can't find anything even that always works for your assumptions, then you might need to make sharper assumptions. Like, I don't know, I just made the assumption that it's causal and not just not a general Bayesian network. That's the kind of thing you could, if that turns out to be helpful, make even stronger assumptions. Right. Let's translate this to the humans Bayesian network. That is the core thing that we actually want, and the solution that is being presented that we are hoping for. And this is the one that will possibly fail. But let's first have a look at why this might work. So in this case, the AI is doing what we want. It has a halo up here. So it's doing what we want. We call it the direct translator. So let's have a look at it again. We have the input here, and we have the action here, and we have here the image of the rubber not taking the diamond. And remember, this is the false image, right? This is what we're seeing on the second video here, and this is not what's going on in reality, because the thief has set up the screen in front of us. Okay, so here on the left side we have the AI's model from before, and in this case we would hope that the AI also has the human Bayesian network, and it transfers its own nodes somehow to the human's nodes, to the value. So there's some kind of function going from the joint distribution from P2 and P7 through some kind of function into the equivalent part of the human's cognition. So like this, for the human, this could just be that there is an attacker, and in the AI it's a much more complex description of the attacker that's just being drilled down into something that is in the same ontology as the human can understand. And so everything of this also maps, like this maps to, it goes behind this node. It's not a very nice drawing here. It goes behind the video node and into H2, and these three nodes go to H3 and H4, and that's the key thing that we are after, because this has the knowledge about the diamond, that the diamond is being stolen because there is this sheet with a fake video being entered. And when we translate that into the humans, then this is in the humans network the part where humans understand as has the diamond been stolen. And in this case, if you ask a question to the reporting module on these two nodes, the question will, does the robber take the diamond, gives the answer of yes. So even though this looks very much like the diamond has not been stolen, in fact it has been stolen, and we can tell that that with this action the diamond will be stolen. And that's of course what we are really after. Now, an obvious question here is, how can we tell that a mapping like this exists? That seems non-obvious, but I could see the argument why that is a reasonable expectation, because a lot of these things have to some extent refer to reality. Like there is a door both in the humans model and in the AI's model, and some kind of correspondence from the part of the AI to the part where the humans think about the door seem like a reasonable thing, like it's going through reality in some sense. So that seems like a reasonable thing to hope, that it would end up like this and everything would just be wonderful and the problem has been solved. We have now solved alignment. Well, not as fast, because we could also get another kind of AI. This here has been written with a pitchfork because that's the bad behavior. And it's called a human simulator, in the sense that we're now doing inference in the human net instead of as in the previous translating to the human Bayesian net. So let's have a look here. This is basically the network that we used to train on, that we used to predict, and what we're doing now, the training that the AI has learned is different. Here it takes the value from the original video and puts that into a new node here. It takes the suggested action and put that into a new node here, and the predicted video and puts into here. And what it does from here is, instead of propagating and doing inference in its own network, it tries to do inference on what would the human believe in this case. So it introduces some nodes that corresponds to what it thinks, what it's been trained to that a human would do. And in this case, once you have like the human's questions here, then you can ask, does the robber take the diamond from, and you ask of this part of the human, and this now no longer refers to, like over here, whether the AI believes the robber would take the diamond, but it refers to whether, in this case, the human would believe that the diamond has been stolen. And so the answer in this case is, like, because it's the same thing as the original human belief, the answer would be no. It has not been taken. And again, remember down here with the picture that is in fact the false interpretation. In this case, this video feed is being projected by the attacker on a screen, and in fact the diamond has been stolen. So what we're seeing here, what is being learned, is what would the human believe if they saw the action and the video sequence. What prediction would they believe? What would they then end up believing internally? And the big problem with this, of course, is that if you try to do this training and testing it on things that humans can understand, then the human simulator will say, okay, the answers here will be the same answers as it has in here because the humans can understand it. And in the cases where the humans can't understand it, well, then it will just basically deceive us, and we will have lost. We will lose our diamonds. And that is the problem that causes this general training scenario to fail. Now we need to answer one more question, and that is, we are training our network in some way. Would we find something that faithfully translates its values into the human neural network, or would we find something that doesn't translate its own knowledge into the human network, but just tries to figure out what would the human believe in this case? Which of these two would we find? Well, the training data was actually not truly on what is the status of the diamond, because we couldn't understand that. It was only what does the human believe. So there's a sense that the human simulator is the correct thing. That's the thing that the AI should learn. In particular, the human might make errors, and sometimes while generating a lot of training data, humans make errors, and they probably make errors in a predictable way. And if you try to train based on how does the model actually work, how does reality actually work, then you won't make a good prediction of that. Whereas if you have a model of the humans, potentially you can predict their errors and get a better, more a better model, one that more correctly that has a lower loss. And there is at least no reason to expect that the direct translator would have lower loss, would be easier or better to find than the human simulator. And so now we found the counterexample to like the baseline strategy, and over the next session I expect to see a number of improvements on that, and also a number of counterexamples to that. So that's what we're going to do next week. But before I go, I would just give my thoughts again on whether we would find the human translator or the direct translator, the human simulator or the direct translator. My intuition is we would find the human translator, and the reason for this is that when we are mapping from reality, this mapping that goes through reality, that when we talk about concepts like a diamond or something that's physical, then sure, I could see that a very smart AI might have the same concepts as we have. But when we're talking about the things that we truly care about, like power, influence, corrigibility, or even values like friendship or things like that, it seems obvious to me that we really have no reason to believe that the concepts we have currently are the same that a very competent AI would find. On the other hand, the human simulator, depending on how capable you believe it is going to be, probably simulating humans and simulating human errors is not that complex. So I could easily see that being substantially more simple. So that would be another reason why we would expect to see the human simulator. But there is an assumption that I'm making here, and that is that the AI is powerful in the sense that it's capable of just learning basically everything. And one of the things we really don't want AIs to learn is how to simulate humans. And I think a strategy around this would center on making AIs that are not optimal for simulating humans, if that is possible. but we'll see what options Paul Cresciano comes up with next week. Thank you for watching, and see you